folks, now we're going to talk about 1.2, displaying quantitative data. So last class we talked about how we can display categorical data in a two-way table, in a pie chart, in a relative frequency table if it's just one variable, two-way table if it's two. So now let's focus on the other side of it. Let's talk about quantitative. So reminder, quantitative data is data that is representing quantities or numerical data. So we're looking at data that is the number of goals scored in 20 games played by the 2016 U.S. women's soccer team. Okay, so this is going to be quantitative or numerical data because each individual in my data set represents quantity, right? The number of goals scored, right? I like to think of it as, can you take an average and does that average make sense? Yes. The average number of goals scored in these 20 games versus if you tried to take an average of, say, your zip codes, even though that's numerical, if I took an average of my zip code and your zip code, I wouldn't wind up in the middle. So make sure if you're saying it's quantitative that you can take an average that makes sense, okay? Is there some potential bias? So bias is when we're maybe over or under, leaning one way or the other. And because these 20 games, I don't know how we picked them. I don't know that much about sports, but I'm assuming the U.S. women's soccer team played more than 20 games in 2016. So how did we pick these 20 games? Okay, so I'm thinking that when we ask about bias, we like to see the word random, okay? So this is not random, so I'm going to say there is some bias possible, okay? So why we like to see random is because then we know that no one's cherry picking the data for one reason or another, okay? So if I'm a super fan of the U.S. women's soccer team and I'm picking 20 games, I'm going to probably pick the 20 highest scoring games, right? Which isn't necessarily a fair or accurate representation of the 20 games. So start looking for that word random, and then that's a light bulb to think, oh, okay, this is less biased, right? That doesn't necessarily mean there's no bias, but we're in the right direction in reducing the amount of bias, okay? So here's the data to the left here, and we're going to represent it below. So here are three different ways to represent numerical quantitative data. And there's another one, box plot, that we'll talk about next class. So we're just going to focus on these kind of basics today. A dot plot, oh my goodness. Not super, you would think I'd be great at this by now, but I'm not super awesome at my Chromebook yet. Okay, so I'm going to use the shape tool here. So a dot plot is just what it sounds like. We're going to plot some dots that represent the numerical data. So we're going to want to start, I'm going to start at 0, even though it doesn't look like there's any zeros. And I'm just going to count by ones. And please do your absolute best at kind of spacing out your tick marks. I don't have the best like artistic or spatial reasoning. So don't mind mine. I did my best. And usually we would use technology to generate these graphs, but it's important to know the basics. So that's why we're going to do some by hand today. And I might have you do some by hand on the next assessment. But in general, statisticians use technology because they are more accurate. Let's be honest. Okay. So let's get rocking and rolling here. So we are going to put a dot on top, not right at the number line, just right on top of the number. Okay. So 5 and 5, I'm going to put 2 dots over there. Now do your best again to make your dots the same size and to space them out similarly, okay? So the way I'm spacing them above 5 should be the same way I'm going to space them above not 0, my bad. Should be the same way I space them above the 1. And obviously there's going to be some error there. So just do your best to line them up. And the reason we have to work hard at making sure all of our dots are similarly sized and similarly spaced is because if they're not, then that could lead to some maybe like we talked about last time, like an over representation of a difference. Or again, if I'm a US women's super fan, maybe I'm going to make the dot above 9 and 10 really big, just to emphasize the games they scored a lot at, right? So that's not super accurate. Sorry for that loud car. I'm trying to teach here. So let's make sure we have like a title, goals scored. I guess you should be a little bit more specific. I'm just kind of running out of room. U.S. women's soccer. And let's put the year. Okay. So there's our dot plot. So we're going to get more into specifics on how to describe and kind of analyze the data. One thing let's be sure of, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I'm going to always emphasize and model that you check your data, double check it if you want to. It's really easy to make a silly mistake, and then that kind of messes you up. All right, so that's a dot plot, folks. Next, we have a stem plot. So maybe you've done a stem plot before, just a vertical line, and your stems are going to be the first 1 or 2 digits, depending on how big your numbers in the data are. In this case, we have a stem of 0, right? That's going to be all of our ones are like 1s, 2s, 3s, 4s, and 5s, those numbers less than 10. And then we have 1, 10. So that's going to have a stem of 1, right? The first digit for 10 is 1. The first digit for all my numbers less than 10 is technically a 0. So this data actually isn't super, I wouldn't want to necessarily use a stem plot for this data. Like, I don't think it's a great data set for it. I'm just kind of giving you an example of how to do it. But usually stem plots are good when you have some different stems going on. But just notice I'm using my dot plot to write the numbers in order, and I'm trying to space them out similarly. So we got our 5s, and then our 9. Awesome. Perfect spacing, if I do say so myself. And then we've got 10, which is going to be down there. Okay, so the stem is 1, so together it's 10. The thing about stem plots is you're always going to want to include a key. So what does that represent? Because, right, this could represent 1.0. It could represent 1 million. It really depends the scale of our data. So always give a key and always give a context. So that means 10 goals, okay? So in both cases, we can kind of see that there seems to be a cluster, or a lot of my data on the left-hand side in those lower numbers. And then it looks like just like a little tiny cluster, just 2 data points that are kind of hanging out over on the right-hand side of my data, or of my graph, okay? So that's something to keep in your noggin. We'll come back to that in just a minute. The last display we're going to talk about is a histogram. So I think histograms are really awesome for when you have a lot of data in your data set. So we only have 20 in ours, okay? So actually 20 is not too bad to do by hand, but let's say you had 2,000 data points. You're not going to want to, you're not going to want to do that by hand. You're probably not even going to want to analyze a dot plot with 2,000 dots or 3,000 dots or something. So a histogram reduces the kind of cleans up the x-axis by making some categories or bins instead of just going up by ones, okay? So, for example, I'm just going to have bins of 2 numbers. I like to call them bins, okay? So I'm going to label my x-axis going up by 2. Now, we could have picked 3. We could have picked a lot of different things. I just arbitrarily kind of randomly decided to go by 2. So there it is. All right, so now what we're going to do is we're going to take our whole data set and shuffle them into these different bins. Now, the only problem is where does 2 go? Is it going to go in the bar to the left or the bar to the right of 2? So you always need to include a frequency table when you do a histogram. Always, 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 because you need to include, does it include the left side or the right side? Okay, so if that doesn't make sense, hopefully it does. I'm going to choose that the left side is included and the right side is not. So you can see from my inequality, little throwback, that 0 is included, 2 is not. Okay, so really in the 0 to 2 bin, that's only going to be 0 goals and 1 goal. Okay, so how many games did that happen in? 6 total. Okay, so I'm going to go up by 2s here. So that happened in 6 games. So it's like that. So it's almost similar to a bar graph, but different because this is quantitative data. And in histograms, you need to make sure that there's no space between your bars. In a bar graph, you will have space. In a histogram, you will not have space. So those bars got to be touching, all right? So 2 is included and 4 is not. So I'm counting up 2 and 3, and I believe that's going to be 8. And again, like I said, you want to represent this fairly, so try to make your bars the same size width-wise. Again, I struggle because I struggle. I'm not very, I don't know, spatial art, again, struggles, but that's okay. So, oops, why do I have a 6 in there? So 4 is included and 6 is not. So I'm going to count up 4 and 5, and I get 4. So that's going to kind of bringing me back down here. Next, I'm going to have 6 included, and 8 is not going to be included. So that would be 6 and 7, which would give me 0. Then I'm going to have 8 included, and 10 is not included. So that would give me just 1 game for 8 and 9 goals. And then last but not least, I'm going to have 10 is included, and it's going to go up to 12, and that's going to be 1 game, okay? So 1 and 1, okay? So that was kind of interesting how that worked out. And again, you can kind of see the same patterns emerge of 2 values on the right kind of sticking out a little bit. And those kind of appear to be our outliers, our kind of funky little data points. And then we've got everything else kind of chilling on the left here. So we've got most of our data on the left and a couple values on our right. All right, so we're going to talk about what that's called and how to do a histogram on a calculator in the next video.